Right, so in our classifying video, we kind of took a look at this diagram and I simplified it. So we had our pyramid, which is rational, which is dealing with fractions, decimals, and whole numbers. And over here we have our irrational island, which is pi and non-perfect square roots. So the purpose of this video is we're going to be focusing in on this pyramid. We're going to be focusing in on how do I get from one of these to the next internally. So fractions, decimals, and whole numbers is what we're going to be working with. All right, so that is our focus, is rational numbers. All right, so the first thing we're going to take a look at is we're going to take a look at how to go from fraction to decimal. Well, I know your calculator has this fancy button, fraction to decimal. All right, I want to make sure that you understand that even with my phone calculator, I would be able to convert these. All right, so first and foremost, you need to understand and remember, a fraction bar in 8th grade simply means division. So this is 5 divided by 7. So that is literally what I am typing in. So again, if you are dealing with a phone calculator, all right, so if I have something as simple as this, 5 divided by 7 equals, okay? So I'm able to get that answer, okay? Now if I turn my phone sideways, which actually I'm in lock mode, so give me 1 second, all right? If I have this and I turn my phone sideways, so notice how many digits are showing right here. When I turn my phone sideways, I get some more digits showing, okay? So you're going to notice that my number ends up going on repeat. So we have 714,285, 714,285, 71, and it would keep going on and on and on and on and on. So when I write these, I need to make sure I am writing all of the digits that are in that repeat. So I'm going to write 0.714285. And then I'm going to go ahead and I'm going to use our repeat bar, and I'm going to draw it over all the numbers that repeat. And this repeats as a batch. So I'm going to draw my bar over top of that entire batch because that entire thing is on repeat. Okay? And that's all it is. We take the numerator and we divide it by the denominator. 5 divided by 7, and I write what I get. Many of you guys have this habit of automatically rounding. We do not round unless they tell me to. All right, so here we have 1 divided by 6. So I have my phone calculator. 1 divided by 6 equals. All right, notice my calculator thinks it's doing me a favor by giving me this 7 at the end. All right, but note, it's not going to be all these strands of 6s and then magically, here's a 7. No, it's still 6, 6, 6, 6, 6, 6, 6, 6, on and on and on. All right, so we would write this one as 0.16. Then once I hit the repeats, I stop. Now my bar only goes over the repeat. I do not put it over this one. If I wrote it over this one, that would mean 1, 6, 1, 6, 1, 6, 1, 6. And that is not what this calculator is showing. So when I record this answer, I want to make sure that my bar is only over the 6. Okay? Then last but not least, we have the instance if I have a whole number in front. All right, well, I could type this into my calculator. I don't need to. If I have a whole pie, I have a whole apple, I have a whole pizza that I'm dealing with, in my decimal, I'm still going to have one whole of it, okay? Then I only type in the fractional component, all right? So in this case, we're going to type in 4 divided by 9 equals, and I get a repeat of 4. I don't write the 0 because I already have the 1 in its place, so I'm going to write my 4. And then I'm going to put my bar over top of the 4 to illustrate the repeat that's occurred. All right, so to go from fraction to decimal, it is simply numerator divided by denominator, and we call it a day. Okay, but now we need to talk about the reverse. How do I then go from the decimal to the fraction? And there's 2 types of decimals. First type of decimal is a terminating decimal. A terminating decimal is the easiest one to work with, because we have to read it exactly how it says. All right, so this would say 800 25, and then we need place value. All right, so we have tenths, hundredths, thousandths. So we have 825 thousandths. So because of how I'm reading it, I'm going to write it exactly like that. I have 825 thousandths that I am working with. All right, now we're going to use our calculator with our fraction to decimal button. So we have 825, all right, and then we're going to use ABC, thousandths, equal sign. So this will simplify to 33 over 40, okay? Here we have 3 and 12 hundredths. 3 and 12 hundredths. So again, I would go ahead and I would do my 12, ABC 100, seeing how this simplifies, and I have 3 25ths. So we would have 3 and 3 25ths. Okay, so that's how we do terminating decimals. We need to use the place values of how we would read it and write it as a fraction accordingly. All right, so let's take a look now at how to convert repeating decimals to fractions. All right, so in this video, I'm just going to be showing you our red calculator cheat, and there's going to be a bonus video on how to properly convert this because the process is a little bit longer. All right, so first and foremost, when you type this into your calculator, you need to understand what's being repeated. So the bar is over the 3 and the 7. So I'm going to type in 0.37, and I'm going to continue this repeat over and over. If I can actually type the 3s, 37. 37, 37, 37, 37, 37, 37. I'm proving to my calculator that there is a repeat. And I need to actually make sure I am pushing the buttons correctly and that it is in fact repeating. All right, and I'm going to go ahead and push enter. So now it's stored into my calculator. And I'm going to push second PRB, so it's going to change it from fraction to decimal or decimal to fraction. So it is telling me that this is 37/99. All right, so I can check my answer, 37 divided by 99, and in fact, I get the 37 repeat. Okay, I can do the same again here. Any guesses as to what this is going to be based on how this one looks? All right, so any guesses? Any guesses? All right, let's see if you're right. So we have 5, 7, 5, 7, 5, 7, 5, 7, 5, 7, 5, 7, 5, 7, 5, 7. Enter, so it's stored in there. So I'm going to push second PRB, and I get 19/33. Okay, so notice this one simplified from this one. Just throwing it out there. All right, so that's how to convert a repeating decimal to a fraction given our magical red calculator. And again, I will be going through a video on how to do this the long way in moving the decimal and the place value if you are interested in learning more. All right, the last piece of rational numbers is that of whole numbers. So our focus in on is perfect squares and perfect cubes because these produce whole numbers. So it's a lot easier when you see 5 and you see 8 and you see 6. You're like, oh, look, that's a natural number. But perfect squares are a little bit more difficult. So we need to make sure we understand how to work with these properly. Okay, so first and foremost, you need to remember that the opposite of square is square root. And the opposite of cubed is cubed root. A way to kind of remember this with our calculator is we have our x squared button. The inverse of that is our square root symbol. We have our caret button, and the reverse of that is whatever root that we're dealing with. All right, so the opposite of square is square root. So I'm going to go ahead and put my radical symbol around that. What I do to one side, I have to do to the other. Okay, so x equals, so I'm going to type in my calculator, second x squared, because that is the opposite of squared. And then I'm going to type in 49, and I'm going to get the answer of 7, because 7 times 7 makes 49. Okay, and that's a positive 7. What we also have to understand with square roots is that we also understand our rules of multiplication. Any number times itself is going to make that perfectness. But what about negatives? does negative 7 times negative 7 make 49? And in fact, it does, because a negative times a negative makes positive. So we need to understand that there are actually two answers to perfect squared equations, a positive version and a negative version of that answer. Okay? All right, so we need to understand that that is how those two work. So let's do this next one. Now, it's a fraction. Well, when I show my work, I need to go ahead and do the top and do the bottom separately. So here we're going to get x equals the square root of 4 is the answer of 2. The square root of 81 is the answer of 9. And we have a positive version and a negative version of that answer. All right. Cubed root and cubed are opposites of each other. All right. So here I'm going to take the cubed root. So I'm going to have a little number 3 sitting on top of that, leaving just x. And what I do to one side, I do to the other. So how do I type this into my calculator? All right, well, I have my little 3, so we have to type him in. And I'm going to type in second and then caret. I'm going to do second and then caret because I want the opposite of cubing. Notice that there is a little x. That little x is pulling the 3. So just like I have a 3 sitting on top of here, that little 3 is going to be sitting on top of there. And I'm going to type in 64 equal sign. So x equals 4, because 4 times 4 times 4 makes 64. So those are the positives. 4 times 4 times 4 equals 64. The question is, does negative 4 times negative 4 times negative 4 also equal 64? Well, negative times negative makes a positive. Positive times a negative, in fact, makes a negative 64. So in the cubed state, we only have the positive version of this. All right, so let's try out this problem. So we have cubed root of 8 over 125. All right, so I'm going to go up here. Cubed root of 8 is 2. And the cubed root of 125 is 5. So we have 2 fifths. Okay. So that is the end of our rational numbers. So again, numerator divided by denominator. We read it as a place value. We use our calculator, and then we compute with the opposite.